Hello. In this video we're going to be factoring polynomials and then solving polynomials by factoring. So notice that the degree, or the highest exponent on each of these, is bigger than 2 this time. So in 1 and 2 the highest exponent is 4, so the degree of the polynomial is 4. In number 3 the highest exponent is 6, so its degree is 6. Now, we can still factor things similar to how we've been doing it before. For instance, in number 1. I see 3 terms here, so I can factor it like a polynomial like I've done in the past. I can rewrite this thing to view it as x squared squared minus 3x squared minus 18. So let's assume for a moment that I say v is equal to x squared. Well, I could rewrite this as v squared minus 3v minus 18. And we know how to factor that. We look for numbers that add to negative 3 and multiply to negative 18. Well, to do my original problem, I'm still going to break it into 2 sets of parentheses, and what times itself makes x to the 4th, well, that would be x squared. And what multiplies to negative 18 and adds to negative 3? Well, that would be a minus 6 and a plus 3. Now we look to factor again. X squared minus 6 is close to a difference of squares, except the number 6 is not a perfect square, so we can't factor that. And x squared plus 3, well, that doesn't even have the minus sign. So this is the factored form for number 1. In number 2, we can do what we did similarly over here. I can rewrite x to the 4th minus y to the 4th as x squared squared minus y squared squared. Now, again, if I was looking at this as, let's say, where a is x squared and b is y squared, I basically have a squared minus b squared, which would be a plus b times a minus b. So I can factor this over here in the original problem similarly. I look at it as x squared minus y squared times x squared plus y squared. And this one right here, the x squared minus y squared, it's a difference of squares. It looks very much like that. We can factor it again. So x squared minus y squared will be x plus y, x minus y, still multiplied by x squared plus y squared. That plus sign saves it from being factored again. And that's the factored form for number 2. Well, how about number 3? In number 3, I'm looking at this as 3x cubed squared plus 5 times x cubed plus 2. Now this one's a little harder because of the coefficient out front. That's a 3 instead of a 1. And so when I do my 2 sets of parentheses, what multiplies to make 3x to the 6th? Well, we want a 3x cubed and an x cubed. And I need numbers at the back end that multiply to make 2, and somehow when I FOIL these back together, we have to make 5 in the middle. And what we'll have here is a plus 2 right there, and a plus 1 here. This is supposed to be cubed. There we go, we'll fix that. And you can see when we FOIL this back together, well, 3x cubed times x cubed, 3x cubed times 1, 2 times x cubed, and 2 times 1. And it would indeed, when we combined our like terms in the middle, go back to the 5x cubed from the center. Now, this right here is what we called a sum of cubes. It's a perfect cube plus a perfect cube. And if we had, if you remember, a cubed plus b cubed, that was equal to a plus b times a squared minus ab plus b squared. So we can do the same thing here. I can leave the 3x cubed plus 2 all by itself, but then x cubed plus 1 will factor into x plus 1 times x squared minus 1x plus 1 squared, or just 1. And so this is actually the factored form for number 3. All right, let's try to solve some of these on the next slide. In number 4, we have 4 terms, and the directions have changed to solve, so we're going to go ahead and do that. When we have 4 terms, we look for our GCF as normal. It is 1, and then we do our grouping. So we group the first 2 together, we group the last 2 together. And then we just perform our GCF work a couple of times. So what's the greatest common factor for x to the 4th and x cubed? Well, it's an x cubed. Still times x minus 5 plus, between 8 and negative 40, it's an 8. And then we have x minus 5 equals 0. So our following step in our grouping, we now have a new common factor in each term of x minus 5. So we'll pull that out front. And that leaves us with x cubed from the first term and 8 from the second term, and we're still equal to 0. So the issue here is x cubed plus 8, that's a perfect cube plus another perfect cube. So I can factor this again. And this becomes, so 8 is the same as 2 cubed. So I have x plus 2 times x squared minus 2x plus 4 still equals 0. All right, so I know that x minus 5 could be 0, x plus 2 could be 0, or x squared minus 2x plus 4 could be 0. So this tells me that x could be 5, x could be negative 2, or solving this, I don't have a way to factor that, and I can't readily tell what x is going to be. So we go to the quadratic formula. So x equals opposite of b plus or minus the square root b squared minus 4 times a times c all over 2a. And so to simplify that up, we get negative 2 squared makes 4. Negative 4 times 1 times 4 makes a minus 16 all over 2. So x is equal to 2 plus or minus negative 12 all over 2. And I'll do that down here. X is 2 plus or minus. Well, from the 12, I can take a 4 out. Square root of 4 is 2. With the I from the negative, with a 3 left in there, still divided by 2. And so our x, our final x, when we divide everything by 2, is 1 plus or minus I square root of 3. So there, you can see I have 4 answers. And we would expect 4 answers because we have a degree of 4. Now only 2 of those answers are real, but we have 4 solutions nonetheless. Let's try number 5. In number 5, we want to factor x to the 4th plus 5x minus 36. And so what multiplies by itself to make x to the 4th? Then we need numbers that multiply to negative 36 and add to 5. So we can do a plus 9 and a minus 4. Now the x squared minus 4 factors again, but I have another option. I can go ahead right now and just say, okay, well either x squared plus 9 is 0, or x squared minus 4 is 0. And we solve both of these for x squared. So x squared would equal negative 9. And then when we square rooted both sides, not forgetting the plus or minus, that x could be plus or minus square root of negative 9. Square root of 9 is 3. Square root of the negative is I. Doing the same thing on the other one. You would add the 4, so x squared equals 4. Square root both sides to get the plus or minus there. And so x could also be, well, plus or minus, and the square root of 4 is 2. So once again, a degree of 4, 4 solutions. Only 2 of them are real, but 4 solutions nonetheless. And for now, we are done.